Distance-time graphs for uniform and uniformly accelerated motion. The change in position of an object with time can be represented on a distance-time graph by taking a convenient scale of choice. In this graph, time is taken along the x-axis and distance is taken along y-axis. In case of uniform motion, object travels equal distance in equal intervals of time. This direct proportionality between distance and time is represented through the nature of the graph. It is a straight line. On this straight line, mark 2 points A and B. Then draw a line parallel to the x-axis from point A and another line parallel to the y-axis from point B. These two lines meet at a point C to form triangle ABC. What does AC denote on the graph? AC denotes the time interval. What does BC denote? BC denotes the distance travelled. What can you conclude from the ratio of distance BC to distance AC? As both the distances will be the same, the ratio will always be equal to 1. Velocity time graph for uniform motion. A train is moving with a uniform velocity of 50 kilometers per hour for 5 hours continuously. The variation of velocity and time can be represented by velocity time graph for this uniform motion. Time is represented along x-axis and velocity along y-axis. To determine distance travelled by the train, draw perpendiculars from the points corresponding to the time t1 and t2 on the graph at points P and Q so as to form rectangle PQRS. What do heights PS and QR represent? The heights PS and QR represent velocity. Now find out the area of rectangle PQRS. The area of rectangle PQRS is equal to PS multiplied by SR. Given that PS is 50, SR is equal to 6 minus 3, that is 3. Therefore, area of rectangle PQRS is equal to 50 multiplied by 3, that is equal to 150 meters squared. What does the area represent? The area highlights the distance covered by the body in 3 hours. Velocity time graph for uniformly accelerated motion. Changes in velocity of a car at regular intervals of time are given in this table. The nature of graph shows that velocity changes by equal amounts in equal intervals of time. For all uniformly accelerated motion, the velocity time graph is a straight line. For non-uniformly accelerated motion, velocity time graph can have any shape according to variation in velocity with respect to time.